Hello student, welcome to my YouTube channel Mathematics Corner. I am Mukul Sarma, subject teacher. Today I shall discuss about solution of some problems in exercise number 4.1, which is about mathematical induction. This is my lecture number 36 for class 11. Last class I have discussed two problems, 1 and 2, in the exercise number 4.1. Today I shall discuss question number 3, that is this is also proved by mathematical induction, that is proved by mathematical induction. That is problem is 1 plus 1 by 1 plus 2. That is 1 plus 2 plus 3. That is dot. That is 1 by 1 plus 2 plus 3 n twice n plus 1. That is. Now solution. Let Pn is equal to, let Pn, at first we take Pn, let Pn is equal to 1 plus 2, 1 plus 2 plus 3, 1 by 1 plus 2 plus 3 n, this is twice n, n plus 1. That Pn is equal to. Step 1, n is equal to 1 implies P1. P1 means, in a series, first term will be here, and in the RSS, right size, we have to put 1 in place of n. Just 2 by 2, that is 1. Therefore, Pn is true. On the left side we have got 1, and in the right side also we have got 1. Therefore, Pn is true for n is equal to 1. Step 2 আমি কৰিব লাগিব. Step 2, let Pn is true for n is equal to k. Let Pn is true for n is equal to k. Therefore, pk is equal to 1 plus 2, 1 plus 2 plus 3, that is 1 by 1 plus 2 plus 3, that is in place of n, we write k, that is 2n, that is 2k, k plus 1. Step number 3, that is step number 3. Now pk plus 1, that is pk plus 1. So write 1 plus 2, 1 plus 2 plus 3, that is 1 plus 2 plus 3 up to k. One term will be increased here, for there is pk plus 1, so one term, এটা term ইয়াত বাঢ়িব, আৰু সেই বঢ়া termটো হ'ব in place of k, Here is 1 plus 2 plus 3. In place of k, we write 1 plus, in place of k, we write k plus 1. 1 plus 2 plus 3, that is dot 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 k plus 1. That is. In the right side of this term is axis term for pk plus 1. pk plus 1 কাৰণে এইটো টাৰ্ম আমি বেছিকৈ লৈছোঁ ইয়াতে, আৰু এই বেছিকৈ লোৱা টাৰ্মটো আমি ৰাইট ছাইডেও এড কৰিব লাগিব। ৰাইট ছাইডত আছে আমাৰ 2k plus 1 অলৰেডি, ইয়াত আমি এই টাৰ্মটো, দিছ টাৰ্ম will be added 1 plus 2 plus 3 up to k plus 1, that is up to k plus 1. Now we have to simplify it just. This is 2k, k plus 1, and what is the value of 1, 2, 3 up to k plus 1? We have got that 1, 2, 3 up to k. This is k plus 1 divided by 2. If there is last term is k, then it is k plus 1 divided by 2. But here last term is k plus 1, so there is k plus 1. Next, k plus 2 divided by 2. This is 1, 2, 3 up to k plus 1. This is k plus 1, k plus 2 by 2. That is. Next, 2k, k plus 1, this 2 will be put here, therefore k plus 1, k plus 2 there. Now we have to take LCM from here. LCM, that is k plus 1, k plus 2, that is 2k, k plus 1, k plus 1, 2k into k plus 2, that is 2. Note that after simplification, we have to get a value this type, but in place of k, we have to get, in place of k, we have to get k plus 1, and in place of this is k plus 1 plus 1. We have to get this value after simplification. If we get this value, in place of k, we have to get k plus 1. In place of k plus 1, we have to get k plus 1 plus 1. Then we can conclude that pk plus 1 is also true. Therefore, after substitution, this is we have to get there is k plus 1, k plus 2. All right, k plus 2k, k plus 2 here. 2k, this is 2k, k plus 2 plus here 2, k plus 1, k plus 2. This is k plus 1, k plus 2, that is 2k square plus 4k plus 2. It is k plus 1, k plus 2, that is if we take 2 as common, k square, 2k plus 1. It is k square 2k plus 1, it is k plus 1 whole square, k plus 1, k plus 2. Therefore 2, that is k plus 1 square means k plus 1 into k plus 1. Here is also k plus 1, k plus 2, this is cancel. Therefore, we get 2k plus 1, k plus 2. This can be written as 2k plus 1, k plus 1 plus 1. So therefore it is true for, because there is pk, we have got pk is equal to, we have got right side, there is 2k by k plus 1, it is a pk. Now for k plus 1 we have got, in place of k we got k plus 1, in case of this is k, we have got k plus 1 and plus 1. So it is true for, therefore pk plus 1 is true for n is equal to k plus 1. So by mathematical induction, Pn is true for all n belongs to n. Pn is true for n belongs to n. This is about the problem. Next problem, that is this is question number 4. That is next problem. That is 4 question number. It is also proved by mathematical induction. That is 1, 2, 3, 2, 3, 4. N into n plus 1, n plus 2. In right side there is n into n plus 1, n plus 2, n plus 3 divided by 4. At first we take Pn. Let Pn is equal to solution. Let Pn is equal to 1, 2, 3, 2, 3, 4, n plus 1, n plus 2 is equal to n plus 1, n plus 2, n plus 3 by 4. Step 1. N is equal to 1 implies P1. P1 means there is first term. There is first term, second term. We have to write first term here. N is equal to 1 implies 1, 3. This is into 1 into 2 into 3. Therefore it is 6. In the right side we have to put, anode height. We have to put 1 in place of n. Anode height আমি 1 বহাব লাগিব 1 1 plus 1 1 plus 2 1 plus 3. This is 1, it is 2, it is 3, it is 4 4 4, that is also 6. Thus we have 6 and 6. So Pn is true for n is equal to 1. Therefore, Pn is true for n is equal to 1. In the step 2, let Pn is true for n is equal to k. That Pn is true for n is equal to k. Therefore, Pk is equal to 1, 2, 3, 2, 3, 4 up to, this is in place of k, in place of n we write k here, n ঠাইত আমি k বহাম, In the right side also, that is in place of n, we write k. That is k plus 1, k plus 1, k plus 2, k plus 3 divided by 4. Now step 3, that is pk plus 1, pk plus 1, that is pk plus 1. This is also 1, 2, 3, 2, 3, 4, dot dot dot, k plus 1, k plus 2, and one term will be increased here because there is k plus 1. But our axis term is what is increasing term, that is this is in place of k. In place of k, we write k plus 1. That is, it is k plus 1. It is k plus 1 and 1. This is k plus 2. This is k plus 2. If we write k plus 1 in place of k, k plus 1 plus 2, that is k plus 3. This term will increase for k plus 1. And this term will so added to this right side. This is, and the right side there is k plus 1, k plus 2, k plus 3, this is divided by 4, and this term also added to right side also. This is k plus 1, k plus 2, this is k plus 3. This is k plus 1, k plus 2, and k plus 3. Now we just simplify it, and after simplification we have to get a value, and this value is this type, but in place of k we have to get k plus 1. That is this type, our result will be is type. In place of k we get k plus 1. In place of k plus 1 we have to get k plus 2. In place of k plus 2 we have to get k plus 3. In place of k plus 3 we have to get k plus 4 divided by 4. This after, if we get this result after simplification of this, then the statement is true for n is equal to k plus 1. Good. Therefore, now we simplify it. This is 4 k plus 1, k plus 2, k plus 3. That is 4 k plus 1, k plus 2, k plus 3. That is. Now we take common. There is k plus 1, k plus 2, k plus 3. We can take common k plus 1, k plus 2, k plus 3 as common. Therefore here there remain k is there. Here is 4. Thus we see that we get the value this type. Therefore we can write. Therefore Pn is true for n is equal to k plus 1. So by mathematical induction, Pn is true for all n belongs to capital N. In this way we can solve various problem about induction. Next class I shall also discuss some more problem. For today I have stopped it.